Hi, I'm Bob with BobsCNC, and today we're going to cover the alarm tube. What does it mean and how can we avoid it? Now I have an E3 set up here. This principle works with the other CNC routers that we have also. In order to understand the alarm tube, we first need to understand the cutting area of the CNC router. So we've taken some blue tape and made a crosshatch pattern so that we can understand the travel. Anywhere outside of the tape, the E3 or the E4 or our CNC routers will not be able to cut. To demonstrate this, I'll take the CNC router from the home position and move all the way to the positive X, the end of travel of the X. Next, I'll go positive Y to the end of travel, and now I'm going to go back to X0, and then back to Y0. Anywhere in between, you will be able to cut. If the router is commanded to go outside of this position, you will get an alarm tube. Now, one thing that is a little bit tricky is the Z is the same way. It will only go 3.3 inches. If you command it to go further than it is now, it will give you an alarm tube. It's reached its end of travel. The same for the positive Z. To explain this further, I've taken a piece of scrap wood and draw the XY coordinate system on there, and now I'm going to place it within the crosshatch pattern. Now you can imagine if we were clamped here, your 0 point would be here. So I would need to jog the machine to the starting point and then re-zero all the axes. You can see I can stay on the entire board no matter where the G code wants to be. However, let's say, for instance, that I had actually clamped it right here. You can see that I would not be able to get back to the back end of the board because it's out of the cutting area. The same would happen if I clamped here. I can't get over to this side. I hit the wall. You won't actually hit the wall because we have soft limits. You will get an alarm tube. And of course, it's probably trivial, but the same thing would happen on this side or if you were further out to the edge. In this next example, I've taken the piece of MDF and I've put the XY coordinate system in the middle. This would represent where the G code would start. So I'll place it on the crosshatch pattern. In this example, you would need to zero the E3 to the 0 point, and then of course you would reset the zeros and you can hit play. And you can see again that it can reach anywhere on the board because it's in the crosshatch pattern. However, the same holds true. This one's a little trickier to see though if you don't understand what's going on. If we barely get one of the pieces outside in our 0 point, everything looks good. However, when the router is commanded to move back here, it will be out of bounds and you'll get the alarm tube. The same thing would hold true if it sticks out too far in the front. It is not able to reach it. You'll get the alarm tube. The Z-axis works the same as the X and Y. We are at the lowest point of travel and the router will be able to move up 3.3 inches. It needs to be in this range or you will get the alarm tube. If you're at the bottom of travel and you cannot reach as deep as you need to reach, you have two options. You can extend the bit out of the collet or you can raise your work. I hope this has been informative and will help you understand the alarm tube and so we can avoid this. If you have any questions, please contact us at helpdesk@BobsCNC. Thanks for watching.